Many modern buildings begin to crack within decades. Yet, some Roman structures have stood for nearly 2,000 years, surviving earthquakes, erosion, and time itself. So, what did the Romans know about construction that we seem to have lost? This is the story of Roman concrete. Roman concrete was very different from the concrete we use today. Instead of modern cement, Romans used a mixture of lime, volcanic ash, and stone. This material was poured into molds, allowing them to create massive structures like domes, harbors, and aqueducts. The most famous example is the Pantheon in Rome, still standing after almost 2,000 years. The key ingredient was volcanic ash, known as pozzolana. When mixed with lime and seawater, this ash triggered chemical reactions that strengthened the concrete over time. Unlike modern concrete, which slowly degrades, Roman concrete continued to grow stronger, especially in wet environments. Modern research has revealed something remarkable. Tiny mineral crystals formed inside Roman concrete as it aged, filling cracks before they could spread. In modern concrete, cracks are weaknesses. In Roman concrete, they became opportunities for the material to heal itself. This natural self-repair is one reason Roman harbors and seawalls still exist today. In recent years, scientists studying ancient Roman samples discovered rare minerals created during mixing. These minerals allowed water to trigger healing reactions instead of damage. Today, Roman builders did not discover this material by accident. They worked in regions shaped by volcanic activity, carefully observing how ash, lime, and stone reacted over time. Through repeated use and refinement, they learned which mixtures performed best in different environments, from dry inland structures to harsh coastal waters. The Roman state also played a crucial role in spreading this knowledge. Engineers, architects, and builders were trained under standardized practices, allowing construction techniques to be replicated across the empire. From Britain to North Africa, Roman concrete followed the same principles, proving that this was not isolated innovation, but a shared system of engineering knowledge. What makes this even more remarkable is that Roman builders prioritized durability over speed. Their structures were designed to last generations, not just decades. In contrast, many modern materials are optimized for cost and efficiency, often sacrificing longevity, a difference that explains why Roman concrete still endures today. Roman construction projects were also supported by an extensive supply network. Raw materials such as volcanic ash, lime, and aggregate were sourced locally whenever possible, reducing transportation costs and ensuring consistency. This practical approach allowed Roman concrete to be adapted to different regions while maintaining its core properties. Documentation and repetition further strengthened Roman engineering practices. While few written manuals survive, architectural knowledge was embedded in building traditions and passed from master builders to apprentices. This system ensured that techniques improved over time, rather than being lost after a single generation. Today, researchers continue to test Roman concrete samples to better understand its long-term behavior. By recreating ancient mixtures in laboratories, scientists hope to develop modern materials that are more durable and environmentally sustainable. In this way, Roman engineering is not just a relic of the past, it remains a source of inspiration for the future. Roman builders also understood the importance of redundancy and resilience. Structures were often over-engineered, with thick walls and layered materials that could absorb stress rather than fail suddenly. This approach meant that even when parts of a structure weakened, the overall system remained stable, a principle still used in modern engineering today. Perhaps the most enduring lesson of Roman concrete is how it reflects a different mindset toward construction. Buildings were created not as temporary solutions, but as long-term investments meant to serve communities for centuries. That philosophy of durability, more than any single ingredient, explains why Roman structures continue to stand while many modern ones do not. Roman concrete was not magic, it was knowledge, gained through observation, experimentation, and experience. It reminds us that ancient civilizations were not primitive, but deeply skilled and innovative. Some of their greatest technologies were not lost, they were simply forgotten. This is Secrets of Time, where ancient history still speaks.